We're going to use a spectrophotometer and a fiber optic cable to measure the wavelength and the intensity generated by excited hydrogen atoms. So we're going to put our fiber optic cable in our spectrophotometer. We're going to tell our software that we want to measure intensity, and we're going to look at our hydrogen tube here. What we have in this tube is a gas discharge tube. The way these are made is you pull, using this right here, you pull off all of the gases that are in there and inject just a small amount of the gas you want to test, and then melt that. So we have a low pressure inside, we have an electrode here, an electrode here, and we're going to put this in our high voltage power supply. So we're going to put our fiber optic cable next to the light, and you can see what wavelengths are being emitted. So here you can see three very distinct peaks, and that makes up the fingerprint for hydrogen. If we move our cursor right to this first peak, you can see that it's approximately at 475 nanometers. If we move to the second peak right here, you can see that it is 485 nanometers. So that's the wavelength. If we move over here to this peak, this one up here, it's 657 nanometers. So those three in the visible are characteristic of hydrogen. No other element is going to give you that same three wavelengths. Now we're going to take a look at neon. So we've got neon in our tube. We're going to turn it on. Your eyes, your instrument eyes can tell you that there is something different. Let's see what the spectroscope says. And you can see there's many more wavelengths that are being produced by the neon. Now we're going to use helium and look at the wavelengths that are emitted by excited atoms of helium. Visually, you can see there is a different color. So what are the colors that make that up? You might want to take a few minutes and what do you think the wavelengths are that make up this color? What you see here, there are two very faint lines, one at about 492, another one about 502, but the three very significant ones are here at about 589, and here, right here at 670, and here at 709. So these five characteristic wavelengths. You can even see tiny ones here that are often very difficult to measure. Small one right here at 728, and another one here at 782. But if you go back to our tube, you can see that it's yellow, that corresponds pretty much to this very intense yellow emitted in this range right here.